Hello, my name is Jess Stacy, and I'm the team lead of Team Olympus, and I'm here today with Clayton Klauser, Daniel Pachko, and Daniel Dorsey. And our group is tackling the private network cloud-based IoT system project. To introduce the project, I wanted to talk about the problem that we're trying to solve. And currently, with the systems that are being used on board the NASA shuttles today, there's a big problem with having to deal with the size and weight and the heat and different aspects of what goes into the system that can really limit its power and its functionality. And we're hoping to expand upon that by creating a wireless private network IoT system that can be used to minimize weight, increase power, and increase adaptability. Okay, to introduce the project, I wanted to talk about the problem that we're trying to solve. And currently, with the systems that are being used on board the NASA shuttles today, there's a big problem with having to deal with the size and weight and the heat and different aspects of what goes into the system that can really limit its power and its functionality. And we're hoping to expand upon that by creating a wireless private network IoT system that can be used to minimize weight, increase power, and increase adaptability. And how we're going to solve this problem is by creating this private network cloud that is going to be able to use to communicate with edge devices and sensors located throughout the shuttle that can send their data and everything back to a centralized server for processing and handling. And then that can then send commands and everything back out to the edge devices, or when they're needed and such.
The system is designed using ThingsBoard to manage the IoT devices. ThingsBoard is an open source cloud package, meaning that it is a type of computer software that's released without a copyright, so it's easily modifiable. It runs on a variety of operating systems, just like Windows, a variety of Linux distros, Mac OS, and it's also coming soon to all the major cloud service providers. ThingsBoard has built-in support for PostgreSQL databases, and it's also scalable through that. And it has a lot of protocols built in for telemetry collection for all your data that's coming in.
Some constraints that come along with this for the IoT platform is that we had to have an open source platform in order for it to be workable and be able to create the functionality that you needed so that you could adapt it to whatever situation that you need. And then it did have to exist on the market today. It would have been hard to make a project for something that's coming out 5 years from now. And then the final and probably biggest constraint is the private network. We had to have it work without the use of the internet because one, there's just no internet in space. So a lot of modern IoT systems require internet connectivity in order to function properly, and finding one that didn't was probably the biggest constraint to the project.
To fully use ThingsBoard, we're actually implementing it with two different applications. The first application is a smart entryway. Essentially what it is the setup of different sensors we have in this door-like structure where we detect whenever someone goes through it. In this model, we're basically doing it to where whenever someone sticks their arm through, we can tell if there's been a human that's gone through that door. To do this, as you can see in our big diagram, we've used temperature sensors, an ultrasonic sensor, a touchscreen, a PIR sensor, a router, and the server computer. The main components of the door are all the ones going off of the Pi. This Pi essentially takes all of this data and pushes it to the server. The way that it does this is that we are connecting it with MQTT protocol. This is a TCP protocol that essentially allows us to have a full duplex of the information between the server computer and the Raspberry Pi. This is specifically used for ThingsBoard. So with ThingsBoard, whenever we make the script for the Pis, for any of these applications, we just put it on there and we just sync up the token IDs and we have them both sync together. A device will appear on the main server on ThingsBoard and you'll start seeing telemetry.
In application 2, we are using a vivarium to hold live plants and show that we can maintain an ecosystem using our IoT network. This is done with an array of sensors that monitor the humidity, lux value, and temperature of the environment. Our Raspberry Pi then sends telemetry data to our server, where based on threshold values we set, a humidifier and heater will turn on to return our ecosystem to equilibrium. Through this, we believe that we have showed how our system can be used for life-critical functions on a remote shuttle or space station.
To implement the Raspberry Pi 4, we used the TFT touchscreen connected by the SPI bus to display the Pi's console and allow the user to run the program that sends the Pi's data to ThingsBoard. The output to the TFT display is done by sending values from the Pi to the server's database. The server is always monitoring the data in the database, and when the values fall within certain intervals, it will increment the count variable. The Pi is always monitoring the count variable, so when it notices that the count variable is incremented, it will output a notification to the TFT display, letting you know that a human has been detected and the count of how many have been detected.
So as you've seen, these are some of the applications that we've done with ThingsBoard. ThingsBoard itself has a bunch of other features that we did not fully go into, but there is plenty that can be used for other applications. There is an alert system and things inside of ThingsBoard you can use for, say, maybe you want to have like a thing to monitor somebody's health. So you could have it to where people are going around the station, have like some wristbands on or something where it can tell their like beats per minute, their heartbeats per minute, or just monitor their health in general. You can do a good amount of other applications with ThingsBoard. It's a very open platform where it's really just you need a microcontroller or just some kind of thing that works as a microcontroller, and you put some sensors on it. Just make sure it can connect and everything. Another thing that can be done with ThingsBoard that we were not able to do this semester was connect essentially with a remote computer to the main server of ThingsBoard, as in simulating a whole thing where you have mission control connecting to what we essentially have as the space station. There is functions there to essentially allow you to remotely connect to a private ThingsBoard server as an additional computer and just essentially come on or log off, disconnect, or do anything in between. So there is the functionality on ThingsBoard for this, along with the huge functionality of allowing you to basically make all these different applications with these commercial off-the-shelf sensors that we set out to find. ThingsBoard is a very good open source cloud IoT platform, and it does match the criteria we were looking for in this project.
As kind of a conclusion, I wanted to talk about our experience in designing this project as a whole. With this project, we really learned how to design, implement, and create a computer engineering product from beginning to end. We learned about creating schedules with deadlines, keeping track of our milestones, really designing a product to fulfill all the requirements that have been given to us, and creating something basically from nothing and going all the way until a final product that we can then send out, and just that entire experience along the way. Here is a brief list of important references that we needed along the way. We used the ThingsBoard documentation, of course, to get everything set up there. Lots of Raspberry Pi documentation, covers everything from like the different sensors that we used and the boards themselves, super helpful. And then the Adafruit temperature sensor libraries. I think this was the only non-Raspberry Pi sensor that we used, so we included the documentation for that as well. I also wanted to extend a special thanks to our professor, Dr. Robin, our lab technician, Alejandro, as well as our NAPA representative, Chatwin, our TSGC contacts, Timothy Urban and Talia Jurgens. Special thanks to all these guys. I know without a lot of the help they would have gotten along the way, this project wouldn't have been possible. Definitely just wanted to say thank you.